Hi, welcome to this video. We're going to work today into Calculus Early Transcendental 8th edition, the diagnostic test functions. So the first question is about this figure for problem 1. So we have this figure for y-axis, this figure for x-axis. So the first question says, state the value of f of -1. So we need to go here to -1, so it should be exactly this. We need to project that into this. So we can answer this, that the answer of f of -1 is equal to -2. The next one is about the stated value of f2. f2 here, as you can see over here, you project. Unfortunately, you cannot establish 100% accurate value. So for this reason, we use this sign, which is like approx, which is not equal, but is approx number 2.8. Maybe an answer could be 2.85, 2.7, right? Because it's pretty hard to get just like from your eyes what is the specific value, but should be something around this one. See, for what values of x is f of x equal to? So we need to know which values we get x and we get y equal to 2. Remember, when we use f of x, it's practically replaceable by y-axis. It's exactly the same, by the way. So here we can get this one, and when we have 2, it should be this point, and it should be this point. So then x should be -3, so you can get 1 square here. It should be -1, -2, -3, and the other one should be 1. D. Estimate the value of x such that f of x equals 0. So when we have equals 0, we get this one, right? So then we can get the f of x equals 0 should be replaced by, well, I didn't say anything here, but it should be x equal exactly to 0. So when this is 0, should be then this value exactly should be, I'm really sorry, I guess that this one should be between this, right, and this. So should be two values. So we can get this one. So I get approx -2.55, which should be exactly this value, and the other one which should be 0.33. How I get those numbers? It's just like calculation. You know that the square of this is 1, so this is like slightly to the left, so it should be a value between 0.25 to 0.33, and exactly the same as this one, as the other one here. We have between -2 and -3, so -2.5 is acceptable. State the domain and range of x. Remember that the domain is the value that the function is established and in the x-axis. So as you can see here, is defined from -3 to 3. We don't have an arrows here. Apparently, if we have some arrows here, so definitely we can see that it goes to -infinite to +infinite, but that's not the case because it's set, it's limited between this. And the range should be like -2, which is this one, to 3. So this is the range of this function. Then we have this one. If f of x is equal x elevated to 3 or x cubed, evaluate the difference quotient f of 2 plus h minus f of 2 over h and simplify your answer. So here the trick is to replace what we have here for 2 plus h, we replace into x. So then we get x elevated to 3, so we have 2 plus h elevated to 3 minus 2, replacing this into the function 2 elevated to 3. So it's important that we need to keep this h so we can cancel them out. So we elevated, so we use this kind of like expression that when we have a binomial elevated to 3 in the sign of plus, you use this parameter. You can do it, or you can arrive to this question, to this answer, just like multiplying a plus b times a plus b times a plus b. You will end up with exactly the same expression. So we just use this one. So then what is a in this one? Is 2. So 2 elevated to 3. In this case, b is exactly 2h. So we have 3 times 2 elevated to like square, right? Times h plus 3. Then this 2 is just elevated to 1, and times h elevated to 2, then plus h elevated to 3 minus 2 of elevated to 3. As you can see, these two like elements are exactly the same, so you cancel them out, and then you just like operate 2 elevated to 2, we have 4, and then 3 times 2, we have 6, and then we have h elevated to 3, right? So then at the end we have 12 h plus 6h squared plus h cubed. So we can factorize or collect this h, and then getting this, you can automatically cancel, and we end with this one just organizing. We like usually just like to present the answer, we start from the exponent that is like higher to the lower, just like this, like a presentation for maths. Then find the domain of the function. So let's start with the first. As we know, the domain is exactly the values that x can get and are admissible, or you can replace into the function. Here we know that when we get this one equal to 0, we're going to get values for x that they cannot be possible into this equation. So for this reason, we're going to find the x values that definitely this function cannot take. So then we just like factorize. So we get like 2 parentheses. Remember, factorize is just like converting an expression that is, we have like sum and or we have like an adding, or we have like plus and minus, and we get into multiplication. So we have x, which is the square root of the first term. The first one is going to be this first sign, which should be plus. The second one should be the multiplication of these two signs, plus times minus, we get minus. Then we need to get two numbers that multiplied get minus 2, which should be plus 2 times minus 1, we have minus 2. Then the other one should be 1, and then should be the sum of them. Plus 2 minus 1 should be 1. So it works. If you are not sure about it, you can multiply them, and you need to finish into this expression. If you don't finish, this expression is not valid for the previous one. So you have two options. The first one, x plus 2 should be equal 0, and then definitely minus 2 cannot be taken into this function. The other one, x minus 1 equals 0, we have x equal 1. Then x should be definitely different from minus 2, and x should be different to 1. Then we can present that the domain goes from minus infinite to minus 2 open, to symbolize that this is open. So we get minus 2 with a parenthesis, not a square parenthesis. Then we have the union to minus 2, from minus 2 to 1, open parentheses, because you cannot use them. And then again, you have the union to from 1 to infinite. This is one way to present, or maybe this one could be all the real numbers minus. So we have these brackets. We have minus 2 and 1. So all the real numbers can be used into this domain except from these two. The other one, we operate exactly the same. So we have x like square plus 1. So then we can get like minus 1. So then any number squared can be minus 1. It's not possible. So you cannot get this answer. It's like we call like imaginary roots. So when we're talking about real numbers, it means that this expression or this domain goes to all real numbers. then the domain is from minus infinite to infinite. Then we need to use the domain of this function. So what we need to know about that? The square root cannot be negative, basically because you cannot find like any number that multiply twice and you get a minus. It's not possible. Let's take randomly a square root of minus 4. Which numbers you can definitely multiply and get minus 4 is not possible. So for this reason is not determined into the real numbers. So is what we're gonna do. We're gonna establish the like kind of the range of numbers or the set of numbers that they cannot be used, or x cannot take those numbers and you cannot replace into these functions. So let's start with 4 minus x is strictly higher or sorry, strictly no, just like higher or equal to 0. So then we have 4 over or equal x, which is exactly the same as x, just like lower. Here it's missing equal 4. On the other one, we have x squared minus 1. So then we can just like separate into two brackets. So x minus 1 factorized, we use like this is like difference of this square root. So we have like x, one parenthesis with minus, another one with plus, and then 1 and 1 should be over 0. So what we use here, so we need to combine these two sets and get the results of the total numbers of x that they cannot be valid or they can be valid, so we can get the domain. So let's start with x minus 1. So if we use this one, we have numbers. This is valid when x is over or equal 1, and the other one is when x is over or equal minus 1. So then here we have the 0, so we establish these two critical points, 1. So it means that when we are over 1, this expression is valid, right? If x is over minus 1, so we have this one, which is positive. Let's take randomly 3, for example. 3 minus 1 is 2, so this is positive. So definitely this expression to the right all the time is positive, and all the time to the left is negative. Again, let's take a random number, minus 5. Minus 5, minus 1, minus 6, so effectively this is negative, all the things that this is less than 1. Let's take the other one, x plus 1. So when we take this one, x plus 1, so then let's, the critical point here is minus 1, and we work exactly the same. All the right numbers, they're positive. So let's take a number, 0. So then here 0 plus 1 is positive. So then all to the right numbers, they are positive. All to the left, they are negative. And then let's use the other one. The other one here, we have here, let's see here. Okay, the answer, okay, what I did here, sorry. What I have here is just like the multiplication of these two, right? So from minus 1, when we get this one, the expression is definitely positive. Between minus 1 and 1, the expression is negative because negative times plus is negative. And the other over 1 plus times plus is positive. Then this is positive. Then for this we have, this is the set for this expression that this one we have like the domain, which is what really care, where we have this positive. So we already solved for this, but this is not enough. We need to take into account 4 minus x. So then when we intersect these both, we already know this set is possible for all positive, that they fulfill this expression. This is square, and let's combine with 4. So then this point, it means that is closed set. So for this reason we use this. This should be like open, like most of the time we use infinite with open brackets. Minus infinite to minus 1 and 1 to infinite. This one is closed. And then when we intersect that, what do we get? We get that from minus infinite to minus 1, we can replace any number into this, and you will get positive here, and you will get positive here. So this is possible. And the other one from 1 to 4, this is determining to this domain. How you can prove that? Let's take again randomly, for example, minus 5. Minus 5, we have here 4 minus parentheses minus 5, so we get 9. So this is valid because it's the square root of 9, which is 3. The other one, we have again minus 5 squared, we have 25. 25 minus 1 should be 24. So you have the square root of 24. And then for this you can get, let's say 3, for example, 4 minus 3, 1 is possible. Square root, we have 9 minus 1 is 8 is possible. And let's take something outside. Let's take here 10. 10, we have 4 minus 10 should be minus 6. Automatically, we know that this is not possible for real numbers, just like for imaginary one that we don't use in this section. Okay, so then for this reason, this is the domain function of this expression. Then, how are the graphs of the function obtained from the graph of f? So we have y equal minus fx. So how we use this one? When we have this one as the fx, which is just like a mirror. This is like the reflect. So this we call that minus fx. So when we have, for example, here 2, the other one you will have like minus 2. So that's like the reflect. The other one, we have y equal to fx minus 1. So let's start with the one that we already know, which is fx. And then basically the trick is like you stretch vertically by a factor of 2. So it means like we have more slope. This is the most, when we have like these two, we have like more slope. And then we have then shift 1 unit underward. So we have this negative. You use like, you basically take 1 unit. And then basically this expression is the 2f of x minus 1. The other one, how we use this one, so let's represent to the Cartesian plane. So then this one is the horizontal shift and this is the vertical shift. So then it means we have the fx. So this value of f of x minus 3 plus 2, it means that you shift 3 units to the right and 2 units upward. So then you go here first, minus 3, and then you go back here, right? So that should be the answer. Then without using a calculator, make a rough sketch of the graph. So okay, we're not using a calculator, so let's have a look on this. So basically, when we have 0, it goes to 0. And when you start going up into the x-axis, y is increasingly going up. And as you can see, these start to getting more and more faster to this. Okay, maybe even you can go just with this, right? Just like go kind of like concave curve. I guess it works because we don't have a calculator. And the other one with minus, it goes extremely like negative, so it increases to the negative part a lot. So this should be like rough sketch of the graph. The other one, how we can graph this one? Well, we know that it's pretty much as the previous one. We just go this one up. So it means that when we have, for example, x equals 0, it's going to be 1 onto the cube. So then we have this one just like going up like 1. And if x is 0, we know that this one, we have y equal 1. And if y is equal 0, we have this expression 0 equal to this. So then we know that should be x plus 1 equals 0. So we have here x minus 1. So this should be exactly its value. Okay. Then let's move here to the other one, which is kind of similar to the previous one. So I just replace x equals 0 to have more idea about this. So we have minus 2 elevated to 3. So then we have here minus 8 plus 3, we have minus 5. And if y is equal 0, we have 0 equal to this one. So we just move the 3 to the left, negative. Then the other one, as you can see, maybe is not so easy to get, right? This x, because we have this like negative. So we don't have calculator, this stuff, so we're just going to keep this one. But if we use here in this expression, we have, for example, if x is equal 0, is equal minus 3 equal minus 8, and then if x equal 1, we have minus 3 equal to minus 1. So I'm just like trying to guessing what should be the number of x, right? So then here it should be a number between 0 and 1 when it is the cut with y-axis. So let's find if there is any max or minimum. How we get this one? We need to derive. So we need to get the first derivative. So this one is a constant, 3, so we get 0. So we have this one 3, then x minus 2 elevated to 2. So just getting this critical point equal to 0. So then we get 3. It goes to the other side like dividing. So for this reason it disappears. Then you get like the square root to both sides. You have x equal to 2. So then replace into this, we have y equal to minus 2 elevated to 3 plus 3, and then just verifying that it works, which is it's just like to get the order value for y, so we just replace into this one. So then we get y equal 3. So then let's find if there is any change of convexity. We take the second derivative. So we start from this one. So we have 6 times x minus 2. We just equal that to 0. The 6 go to the other side, which is, you just get 0. 0 over 6 is equal to 0. X is equal to 2. So then getting this, we're going to have a look if this where the function grows and decreases. So we use the first derivative. When it's positive, this function is going up, and when this is negative, this function is going down. So then, because this is squared, it means that it grows all the time. Evaluating the convexity, we have this second derivative, and we know that when x is smaller than 2, then this one is going to be negative, right? So then when it's negative, this is concave. And then when we have this one is larger than 2 when it's convex. Then replicating all the things that we did, we have first, the first thing, we have this one, which is a value between 0 and 1, this one, which is the cut with the y-axis. This is the first thing. We know that all the time this function goes up, and we know that it changes from concavity in the value of 2. And how we know these 3? We just replace into this 2 minus 2 is 0, and plus 3 should be 3. So this is the sketch. Maybe it was kind of more complicated to the other ones because we went more into details, right? But I guess that we did it. Okay, without using a calculator, make a rough sketch of the graph. So again, I did something similar. We have f of x equal x squared. We already know that this is something like this, but because this is in the negative, so then it should be something like that. It opens to the down part, and then we just get this one, the 4. So we take this one up 4 units. So at the end of the day, we finish into this one. And just getting these numbers, okay? So we have, if y is equal to 0, we have 4 minus x squared, and then in this case, we have this one, which is 2 minus x times 2 plus x. So we have two possible values, x equal to 2 or x equal to minus 2. So then these values are the cut into x-axis when y is equal to 0. then the other one should be the square root. The square root, we have that if x is 0, y is exactly to 0. And then here we have the first derivative, which is kind of tricky because x is like elevated to 1 over 2. So we take 1 over 2 out, so we have 1 over 2, and x 1 elevated to 1 over 2, or a half. You take minus 1, you have now minus half. So when we have on the numerator some negative exponents, so we can take positive if we take down. So we have 2x elevated to 1 over 2, and then the second derivative is negative. And why it's negative? Because the 1 over 2 is like kind of negative exponent. It goes down, and then multiply by 1 over 2, we have 1 times 4, and 1 minus 1 over 2 minus 1 is exactly the same as minus 3 over 2, and we take down to the denominator. So this is concave. So with this one, we can assume that the value is going to be something like this. Maybe sometimes we can use like the negative ones, because when we have 4, we have two answers, minus 2 or 2, right? Because minus 2 times minus 2, the answer is 4, or 2 times 2 is 4. However, because we're using functions, and remember the definition of function, for any value of x number, you just have 1 into y. So for this reason, we're just replicating the positive numbers, so we can sketch this one as this part. The other one is basically the same, just like it 2 times the previous one. So we just we need to get steeper, right? This one. And then the other one, it's minus 2 elevated to x. So then here, I use something like this. Why? Because any value that you use of x, for example, x, imagine that is 2 negative. When it's 2 negatives, this exponent goes to the denominator. So you have 1 over minus 2 elevated to to a huge number. It will bring a huge number too. So when we have 1 over extremely huge number, imagine just one pizza for 1 million people. It's going to be really slight, right? So definitely you get something close to 0 from the negative side. From the other side, when we're using like so positive, like so huge x, we are getting a huge number but negative. So for this reason, it's going to infinite into the negative side. The other one, y equal 1 plus x elevated to minus 1. So the first thing that I did to understand this a little bit better is 1 over x, again, because x elevated to a negative number, it goes to positive into the denominator. So x definitely cannot be 0. You can put into your calculator, into Excel. Then 1 over x, so x cannot be 0 because it's going to be undetermined. So each time x gets closer to 0, the fraction tends to be a large number. Why? Take 1 over 0.000001, and you will get like incredibly like huge number. So then the other thing that we can know here, like y never can be 0, could be something related to a number of 1, right? So we create like a asymptote here into 1. So then when we go to extremely x number so small, right, we're getting to this one to a huge x number, negative. So we're getting this value so small. So 1 plus we should be negative, 1 minus is slight part, so it goes, or it tends to be 1, but it never is gonna be 1. When we go to 0, then here we're going to get huge number here, but negative. So these negative numbers, just plus 1, it's not gonna make like great difference, this one. So anyway, it's going to be here. It never gonna be 0. Y never can be 0. And then from the other side, if we start from the 0 part here, just small numbers, positive x number, you're going to get here huge numbers into y. And when you get to higher numbers into x, you're going to get this approx 0. So this goes exactly to 1. So then the asymptom that we have here is going to be 1. So this value is going to be 1. The other, we have this. So we have this, which is like in parts, 1 minus x squared if x is lower or equal 0, and 2x plus 1 if x is over 0. So we need to evaluate when f of minus 2 and f of 1. So let's start with minus 2. When we use minus 2, what we should use? 1 or 2? So we need to use this one, right? So we're going to use 1 minus x squared. So we just replaced, let's just like take care into this minus 2. It's like common mistake. Just like replace this into this. So we're going to get positive number. So then we have f of minus 2 is going to be exactly equal to minus 3. F of 1, we use 2x plus 1. Then we replace, so we have 2 times 1 plus 1, so we have here f of 1 equal to 3. So then how we sketch this graph? So let's start with this one. So this is the expression of x squared 2, because it's negative, so we know that it opens to the down part, and then we just add 1. So we know that this is the expression. But this is going to be valid just with x minus, x lower than 0. So then it's going to be exactly this. And then the other one should be 2x plus 1. So when x is 0, you get here plus 1. So then it matches exactly in this point. And then it is going to increase because this is 2x positive, so it's going to increase in this. So this is going to be the value or the graph of x. The last one, last but not least, I'm tired already. Okay, here we have if f of x is equal x2 plus 2x minus 1 and g of x 2x minus 3, so we need to use this function. Is what we read here is like f composed of g. So we can like express like this as well. So we just replace f of g of x. So then here when you have this x, you replace for this. So instead of putting x, you put 2x minus 3 and then 2x minus 3. Then we use this one, the square like subtraction binomial. So we have a minus b elevated to 2. We have a2 minus 2ab plus b2. Then we have this one. Then this elevated to 2, we have 4x squared minus 2 times 2x times 3. Then this 3 squared is going to be 9 plus 2 times 2x is 4x, 2 times minus 3 minus 6, and then minus 1. So getting this, we have this one, 4x squared minus 12, 2 times 2 times 3, plus we have here 9 minus 7, so we have plus 2 plus 4x, and then those common terms minus 12 plus 4, we have minus 8x. So this is the final answer of f of x composed. The other one should be the opposite. In the time that you have x here, in the part that you have the x here, you replace by this. So instead of putting x, you put x squared plus 2x minus 1. So we just multiply 2, all this, like by distributive law, 2 times x squared plus 4x minus 2 minus 3, and then at the end of the day we finish with this one, just like minus 2 minus 3. The other one, g compose g. So I suggest start with this one. So instead of putting x here, you're going to incorporate, or you're going to plug 2x minus 3 here. So you put here, so you have 4x minus 6 minus 3. It turns out 4x minus 9. So this value is going to be inserted again into this. So we have 4x minus 9, and you have here 8x minus 18, and then minus 3. Then at the end of the day, you have 8x minus 21. So, okay, definitely, if you get into this part, this was because it works for you. I really appreciate that it works for you. I apologize, maybe have some mistakes, maybe for my language barriers, maybe it was not a barrier. Okay, thank you so much for watching my videos, and definitely see you in the next one. Have a great day. Bye bye.